So these lightning talks are, intended to provide thought-provoking conversation, quick flashes of ideas to get the mind going a little bit. Encourage you all to talk with one another about what you hear and explore different ideas together. They're not intended to be a company pitch, though obviously, we want to hear about the solutions that your company provides. But I always suggest to folks that when presenting, you want to present what the problem is first and then the solution. And lightning talks are a great way to do those layups. Do we have Henry with Safecom Wireless? Great. So Henry's up first. Henry is the CEO of Safecom Wireless, and he's going to be talking about why we've all been doing public safety DAS wrong. Thank you.
Thank you for your time and your attendance. So today's topic is what's the difference between public safety and commercial DAS. So those who you are in the field know that there is a difference, so let's just highlight it. And more specifically, we've been doing public safety DAS all wrong. Not so much the integration community, but the equipment community. So let's review a history to know where we came from so we understand where we are. The first DAS was commercial DAS, right? Wireless needed to be ubiquitous. BFFs were tweeting LOLs to each other from everywhere. So that market was rich and large, and it grew very quickly. The equipment market responded. They designed equipment that was suitable for commercial DAS. They didn't worry about things like power consumption, battery backup, redundancy, efficiencies that public safety is very interested in. So if you were to start from scratch and design a public safety solution equipment from a clean sheet of paper, what would you do? So first of all, because of the well-known complicated frequency bands in public safety, you would make the system modular. You would make plug-in cards that are dedicated per frequency so that you have the control on a per frequency basis, on a per agency basis. You would make them very efficient in power because you're going to be running them on battery backup at some point. So you don't want a monster, for example, monster amplifier where all the signals go through and it's on all the time. Public safety is push to talk, so 90% of the time the system is not transmitting. So you wouldn't want to ideally be drawing 80% of the power of the system while the system's not even being keyed up. Secondly, redundancy is very important. You would want a system where, again, all the frequencies and signals don't go through multiple single points of failure. In a modular system, you would have the opportunity to have a modular standby. So you would design a system that would be nearly free of single point of failures. A system where multiple cards support individual frequencies and any one of them can switch over to a single card built inside the system for redundancy. Rather, the way the cellular solution has to work is you need another whole second box. And then, God forbid, you need a VHF band or UHF band. Now you're adding multiple boxes with multiple redundancies, and it becomes very inefficient, very costly, and tough to make money in that case. Finally, what you might want to do is add some other features that Homeland Security, public safety folks want. If you were to look up technology gaps for Homeland Security, they have a list of things that they need to protect their first responders and the public that they don't have yet. One is ubiquitous coverage indoors for radio. And second thing is tracking of first responders. When they run into a building that people are running out of, the commander down at the base can know where everyone is, and distributed sensors throughout the whole building that tells you where's the chemical spill, where's the other type of threat that the first responders are facing. And you would have that on an iPad or computer and a map of the building, and so you could see your people. You have radio communications, and you could see the threats. So that's how we would do it if we wanted to start from the beginning, and that's essentially what we've done. So we have a solution that's modular. If you have 4 800 megahertz channels, 3 700, 2 UHF, 1 VHF, you can just pop in a card. And they're redundant internally. A single card provides redundancy for a single band, not another second box. And it's done based on highly efficient dedicated amplifiers per channel. So that means if that frequency is not being used, you're not drawing any power. And so highly efficient, modular, and added features of distributed sensors and tracking so that once you are pulling in the infrastructure for DAS, you can add more features and sell up to a higher performing product to your high-end customers like port authorities and transits. My name is Henry Wojtunik. I'm with Safecom Wireless. Thank you.
Excellent, thank you so much. Next we have Deepak with Keysight Technologies. Deepak is a sales engineer and he will be talking about RF analytics in HetNet DAS, small cells, and Wi-Fi. Come on up, thank you.
Thank you, Elisa. Hi everyone, I'm Deepak Sivakumar. I'm with Keysight Technologies. I manage sales engineering for the data analytics and the data collection platforms at Keysight. A little background about Keysight Technologies. We were formerly Agilent Technologies, which used to be HP, and our focus is mainly on the test and measurement solutions, which allows our customers to really check and analyze the health of a DAS network or any RF network in that case. And in the last 3 years, what has happened is, me personally, I went through 2 acquisitions. I was with the Nemo Wireless Solutions Group, but acquired by Keysight. So with respect to the audience and the focus, which is DAS mainly, our testing as well is very focused on DAS and small cell, and that can be for indoor, outdoor, whether it is for VoLTE or voice over Wi-Fi, carrier aggregation. There are so many different areas within RF testing that we focus on. One of the problem statements that we address is the analytics that come from venues that otherwise engineers or even senior management does not have access to. So usually in a venue, when you go do your testing, whether it is a benchmarking walk, or it could be a site acceptance walk, or it could be for a neutral host or carrier-owned. What happens is after the walk is done, all this data is collected, brought back to the office, and it takes a long time to turn around results. The products that we put in place, both from the data collection all the way to the processing, allows you to do all of this when you're on site. So the problem statement is, it takes too long to actually turn around and give results back to your end customers. So if you're a services company, it takes you, if you're working with an 80-story building or say a 50-story building, it takes you weeks to turn around and give results. But with our products, with our post-processing products, WindCatcher mainly, we can turn around and give results back in less than a day. So that time frame that we provide is very aggressive and allows you to close more projects and go win more projects as well with your end customers. So that is the problem statement and how we address it. So different flavors of our products that helps address DAS issues. Mainly if you have a tester, say he's doing a benchmarking test, you have a newly owned building, a neutral host, and you turn on the DAS and you have your DAS tester walk the venue, and you have all these results collected. But instead of taking that back to your office, we provide solutions that allow you to analyze and see analytics on the field that tells you if you're, that tells you who's performing best in your venue. So what that allows you to do is you don't really have to fly engineers back and forth around the country. You don't have to roll truck. That is the main essence of it. So you're saving all of that operational expenses. And especially when you think about site acceptance, where say, an operator decides to deploy VoLTE in a given system, or VoLTE or voice over Wi-Fi, CBRS testing, whatever it is, the time it takes to actually do all of this it takes too long. but we can quicken that process, which tells you red light, green light is your when you pass or fail. That allows you to move to the next stage in the process. Anyway, again, I'm Deepak Sivakumar, and I'm here with my account manager, Susan Seeley, as well. Please talk to us if anything, and very nice to meet all of you. Thank you.
Thank you. Thanks so much. Ed, you're up next. Ed Donovan with Telecom Infrastructure, he's the president. We'll be talking about moves, adds, and changes to existing DAS systems, trends, and techniques to maintain quality. Thank you, Ed.
Thank you, Alyssa.
Good morning, everyone. So I'm the guy that has to put the stuff in and maintain it, and I want to talk to you about DAS MAC work, day 2 connectivity, some of the steps to take to be proactive in maintaining an existing IDAS in-building solution. So first off, what we're looking at is a kind of a maintenance agreement with the building owner. We have about 7,000 antennas that we've installed, and the tenant space for these vertical high-rise commercial buildings, as well as the MDUs, have a tendency to change over time. And whether it's a single-tenant multi-floor or a multi-tenant multi-floor, we have retrofits, restacks, and things that are constantly happening up in the ceiling. That's our space. We own the ceiling. There's 22 different technologies, but DAS is very, very fragile. And what we're finding is that there's a lack of coordination between the building owner and the tenant construction general contractor when they renovate space. So I want to kind of walk through some of the steps regarding the antennas. One of our first steps is to notify the carrier that when we're talking with the building owner, the chief building engineer, or the building manager in particular, they notify us that there's going to be retrofit going on in a tenant space. We'll coordinate with the carrier, we'll identify the RU, we'll take a look at the topology. Either we have an on-site IB wave topology on file, or we do a Class A connectivity audit to understand the topology within the building, because very often this particular floor space that's being renovated may not have the active remote unit, right? So in the case where you're doing a phased approach where there's only a partial floor, you're not going to actually address the RU, you're going to go out to the splitter. Those are very, very difficult to identify without a roadmap, but nonetheless very important not to shut the entire system down if the floor is only undergoing a partial renovation. Once you've identified the system, you can tag and flag the half-inch, typically it's half-inch helix coax, tag and flag it so that when the demo is happening that this cable does not get wrecked out. Very often the antennas will get wrecked out. Those are pretty inexpensive commodities. You're going to have a difficult time matching the same antenna because of the technology changing. Nonetheless, you can get an equivalent antenna. They're a little bit small, lower profile these days, so but be prepared for that because the antennas do get beat up. The coax, if you can maintain that, you can protect it by tagging and flagging it with tape. Some of the trades will not wreck it out, especially if it's up over all the mechanical, electrical, plumbing technology in the building. So once it's identified, what you want to do is you want to proceed by identifying the RU or the method at the splitter and power the splitter down and to turn the system off for that particular floor. If it's a multi-floor topology, then you want to get out to the splitter and you want to disconnect that leg, put a resistor on the splitter, and disconnect that leg so that there's no more end within the system radiating cable when it gets cut or if it gets kinked, that sort of thing. The tagging is important, but very often the cable gets ruined. And what we're finding is retrofit with regard to a particular floor is the ability to install new coaxial cable, new splitters, new connectors. Very often, some of the carriers are adopting different types of connectors, so there's an opportunity for PIM-rated connectors to be introduced in the marketplace. You want to make sure your connectivity is acceptable in that regard. When you do install the cable, you want to be aware that about 75% of the ceilings do not any longer exist in New York City anyway, so the color of the cable is very important, and it can be painted to match the aesthetics of the ceiling. So those are some of the kind of tips that we have for DAS MAC work, and I'm glad to be able to present to you today. Thank you.
Excellent. Thank you so much. Next up, we have Marty. Marty Coleman with Dewberry. Marty is the Director of Construction Telecommunications, and he'll be talking about turnkey DAS solutions. Thank you.
Hi, for those of you that don't know me, I'm Marty Coleman. I've recently accepted an offer from Dewberry Engineers, one of the largest and best engineering firms in the U.S., over 2,000 employees, and I'll be a Director of Construction for Telecommunications. And just wanted you to know that we now offer the full turnkey solution from RF design through A&E design, construction, and commissioning. That's pretty much it. I'm done. Thank you.
Excellent. Thank you so much. And last but not least, we've got Dan Lowe with Voltserver. Dan will be talking about touch-safe power for mobile convergence. Thank you.
I'd just like to say thank you to NEDAS and Alyssa for giving the opportunity and everybody here with your time, which is very valuable. So the challenge was to maybe set up a problem and try to have a solution for it. So for everything we're talking about, I think it's already accepted. Convergence is happening now. Mobile densification is a requirement. Building owners really need mobile convergence, and densification is a fourth utility. We're all addicted to doing our jobs, watching Netflix, watching sports events, streaming like World Cup events. So we know this has to happen. So the challenges we've always seen in our company is in the power business is you're going to have to put radios and convergence devices and IoT devices in more and more places that you never thought that was where you were going to have to get power, as well as fiber, which we've talked about today, and some copper in the form of PoE, Ethernet, and 15, 25 watt power over Ethernet to power phones, maybe a very small, low power, small cell. So the challenges for us are to make this work, and the capital structure is changing also. AT&T, Verizon Wireless, T-Mobile aren't necessarily going to fund a DAS system unless it's in a very marquee facility. We're actually fortunate enough to be doing a new Major League Baseball stadium now where AT&T, T-Mobile, and Verizon are all driving the installation. Big 225 kilowatt operation, obviously marquee event, lots of money can be invested and get a return on it. But the big challenges are how do we speed installation, get speed to revenue once you've got that commitment from the customer, or the real estate owner knows they've got to turn on better mobility or wants to enhance their service reputation. How do you slash the cost of installation? How do you recover your cost of getting power as well as the data in at installation, not needing an ROI calculator to bring that back to you? And move, add, change, you just made a great point on move, add, and change. You need flexibility. If you get a new tower outside and you get dominance and you need to move the small cell, you want to add a 5G, you may even want to add mobile edge compute. To me, IoT is power plus communications, which is obvious, but it's also compute. You'll start to see mobile edge compute wanting to sit next to a facial recognition computer. You'll start to want it to sit next to IoT traffic sensors to make local decisions, where latency is so important, why even take a leg back on the fiber? So very simply stated, what Voltserver has brought to market, we have an invention called digital electricity. Very simply stated, we take a transmitter that looks like an IT gear, literally a Voltserver, and you put this where you want your battery back. This can sit in a crappy piece of real estate that's not worth money. You can put us in the gray space. You can put us in a cabinet under the seating in a football stadium where they can't sell hats and caps and beers. And then all you basically do is connect this either to a 48-volt battery or connect this to an AC circuit. You plug little tiny alarm cable essentially into each of these ports, and the magic is our safety protocol. We send 700 little packets of electricity per second. We actually de-energize the line and we look for safety every one of those 700 checks per second. Everything cool, we keep sending pulses. If something wrong, we turn it off. What we do at the other end, small receiver, we convert the energy back and power DAS remotes up to 1,500 watts. We power PoE switches up to 1,700 watts, but also smaller ones. We even can power LED lights and IoT beachhead gateways with this product. Now you have centralized backup. Very last thing we do, we have policy software. So you can decide who gets backup when. So if you have a problem, the AC grid goes out, you might leave emergency lights on, you might leave the regular consumer DAS on long enough to get evacuation out of the building and make your 911 phone calls. And then finally, you'll leave your public safety radios running on the battery plant. So you don't need IDF space. We can hit points up to 5,000 feet away. We're in the top floor thanks to Extenet and the Willis Tower in Chicago from the basement up. Thanks to Verizon, we're 4,000 feet from radios in the parking lot of Patriots Gillette Stadium. And thanks to AT&T, who gave us our first job ever. They had us do a college football stadium day one. There was about 40 1,500-watt DASs in that stadium we were able to hit from a single cabinet. So if you're interested in a way to slash costs and speed installation, power is just as important as data and sensing and latency. Thank you very much.
All right, thank you. We do have time for one more if anybody wants to be a brave person. Yeah, come on up. Since we didn't have you sign up earlier, you'll have to introduce yourself and present your topic, so thank you.
Thanks for letting me barge in. My name's Hal Kern with Powercom. Like Ed Donovan of Telecom Infrastructure, we also specialize in the interior DAS space. But one of the things that I think differentiates us from some of the other players out there is we've been doing interior DAS for more than 10 years, and most of our projects are very challenging venues such as airports, World Trade Center, healthcare environment. And I think a lot of us involved with interior DAS know how challenging some of the installations may be, from working with very large stiff cables such as half-inch coax and larger, to all the testing challenges involved. Try to pass PIM in a healthcare environment, it's virtually impossible. But we also do customized solutions, including custom fabrication, kitting of DAS installations. So in other words, if you're looking to streamline an installation and lower your installation cost, we'll come out and engineer a whole kitted solution, meaning we'll have pre-cut, pre-tested, sweep and PIM tested cables, kitted, palletized. We'll set up all of the head-end closet gear ahead of time, also palletized, delivered, labeled, pre-tested. And very often that's one of the most difficult tasks to do in the field, especially in a hospital where you might be working inside of an environmental mobile tent system where a guy has to stand on a 6-foot ladder basically working like an asbestos worker, and try putting on half-inch connectors on coax inside of a tent with your head above the ceiling. So we also, one of the newer things to come to market, it's just been recently approved by several of the carriers, is a completely non-coax based interior DAS solution. No more half-inch coax. It runs across category cable, uses backbone in the fiber, and it's a much, much more cost-effective solution with not only very high performance, but it's a software-driven system that can easily accommodate 5G down the road and other technologies. And one of the other niceties of some systems like this is the ability to not only handle neutral host DAS for the 4 major carriers, but it can also simultaneously support first responder systems or auxiliary radio systems for facilities managers or emergency personnel. That's rarely done on today's traditional DAS systems. And even though some authorities would prefer to have discretely independent systems, not have the cellular DAS run on the same pathways as first responder DAS, they're also trying to encourage building owners to install more of the emergency communications. And the only way to do that is to try to make it a little more affordable, and having systems that can support multiple technologies without having to run separate discrete cable systems could be very advantageous. I want to thank you for letting me have this time and barging in as the mystery guest. I appreciate it.
Thank you.